Howdy, welcome back to the shop. Hey, today we're going to do a little video. It's going to be more of a show and tell than a build video because I do have a build series on this little Spinamajig, but it is not under 20 minutes. It was about 2 hours long, and I edited and whittled and played, and I couldn't get it to under 20 minutes, and that was my criteria. So I'm going to have to do a kind of a show and tell style of video on this Spindexer. Now there will be a playlist at the end of this video for the build series. It'll be a 2-part, maybe a 3-part build series on this. And that way, if you want some in-depth detail and not just me blabbering on, then we'll go from there. So let's get this thing tore apart, and I think I'll just take it apart and then rebuild it and kind of do a show and tell on each individual part. So we'll start with the plates. The center hole here is about 1.5 inches. The OD on them is about 3.5. This bolt circle diameter where they mount on the Spinamajig is 2 inches diameter. The register hole is 3 inches diameter, and this one is a 24 hole. That way I can do a 6, a 4, a 12, a 24, and 8. You get the picture. And I have marked, there's a mark right there, a little file mark. So that will be my common start. And then I've got 6. Now I know that these 3 holes are going to be on, if I'm going to cut 6 flats, I know to go to a 6, and then one that lines up with a bolt, and then a 6, one that lines up with a bolt, and then a 6, and one that lines up with a bolt. Simple. Same way at the 4. Start at the notch, 4, 4, 4. Then you're back to the notch. I did a 10 hole. That way I can do a 5 or a 10. I guess I can do a 2 as well. A 2 flat, a 5 flat, or a 10 flat. If I needed to do, like, I don't know, at some point I might try to cut a cogged pulley or something like that. I can always make me a new disc. I don't think I can go past about 28 or maybe get a 30. Because it's going to get very thin. You start adding more holes to get very thin in between the holes. But, it's something to play with, and I don't have no money invested in this. This was steel that was laying in the steel pile. Okay, here's my base. Now this material is 1 by 4 inch aluminum from the junkyard. And I just traded for this. I swapped off some scrap, that AC scrap, air conditioner scrap. I'm a heating and air guy. I got lots of air conditioner scrap laying around, scrap copper and things of that nature. So they had this. I swapped off some of my ACR scrap. This was $2 a pound. It's 1 before, unknown alloy. Don't care what alloy it is. It's aluminum. That's all I need to know. These bearing bases are about 2 inches tall from the parting line to the bottom. I fastened them in with just flathead machine screws, 1/4 flathead machine screws. Works good enough. Gives me enough room to knock it around and get it adjusted true, because with my level of precision, nothing in my world is going to be square, accurate, or true, so you got to leave room for adjustment. This bore is 1.700. Well, the shaft is 1.700. These are, before I milled the relief for the clamp, I think this one was 1.705, and this one was 1.707 inches. So that gives me plenty of clearance in here. But not enough that I've got slop and wiggle room. I will say that I cut this material with a skill saw, just a regular old worm drive Bosch skill saw, with a regular old wood cutting carbide blade. Now it makes a lot of racket. You got to go pretty slow, but if you don't have a good metal cutting bandsaw, and I don't yet, it works. It's probably dangerous as heck, and if you cut off your arm, then that's your own fault. Don't try this at home. My bearing caps are just bearing caps. I obviously had these clamped to the bearings when I milled them. I had to do these one at a time, and as I did them, I indexed. I had these ganged together, both the bearing sets, ganged together, and drilled an 1 3/8 hole through with the bottom surface here lined up as good as I could get it. And then I indexed with my coax indicator to get lined up on the milling machine to bore them with a boring bar or boring head. I did introduce some air in it. So what I did after I got my holes bored to tolerance is, of course, they were unbolted from the base at this point. I flipped them upside down with the spindle in there and decked them off on the bottom. That way it was basically, it may be running uphill or downhill a few thousandths, but at least it was straight. It was on the same plane as the center line of the axle shaft or the spindle shaft. The bearing caps, sorry about that. The bearing caps are drilled through on the cap, clearance size for 1/4 20, flathead machine screw. The bottom, the bearing saddles are tapped, and being this is 2 inches long, and I looked and I did not have a pulley tap. I tapped from this side and then tapped from this side. Now where it meets in the middle, those threads are useless, but honestly, if I've got 3/4 of an inch of thread engagement, that's plenty. You know, that's about right. I don't need a whole lot of thread engagement on that. You know, 3/4 of an inch with a steel bolt and an aluminum block is about as good as you're going to get for a quarter inch bolt with no more torque than I'm going to put on these. Now I did put a stud in there for this side instead of having something that's constantly wearing on the aluminum. And I made me one of my fancy nuts that fit my special wrench that I use on the milling machine and lathe. And just about everything on my lathe and mill that is something that needs adjusted, twisted on, worked with, used in daily operation takes this wrench. That way I don't have to fool around looking for 11 different wrenches. I can just grab this wrench and bang, you know, I've got the right wrench. The downside to that is when I lose this wrench, which I haven't lost this one yet. So anyway, there's the nut that locks this down. Now this flat, after I got everything built, I put this on the mill and I just took 20 thousandths off of this surface here, and that gives me enough relief that when I clamp down on this, it locks her down. It locks it down tight. You can actually lock it with just fingers, and I can just tighten this up by hand, and it's tight enough that I can't roll the spindle. Okay, the lock. Whoop. Boy, that looks crooked in the camera. Weird. Huh. So this is just 3/8 coarse thread hole that's been drilled and tapped. And the way I generated that was I had this all assembled, put my plate on the spindle, and then reached in there with a transfer punch and just transfer punched it out, and then put it over in the drill press, drilled it, tapped it, so forth. This is a piece of 3/8 bolt, or actually this was 3/8 all thread. Turned the threads off the end of it, put a screwdriver slot in it just for in case. This thread's in there like so. Now this does have a very, very slight taper to pretty much allow for any misalignment. You know, you can run this taper in and out just a hair, and it will give you a little bit of fudge room, shall we say. And another thing that I found just by happy accident is this flat has to be turned tangent to this radius, like so, in order to gain clearance. If this gets too loose to actually hold it in position, I'll have to take and grind or sand a little bit of this nut face off so that I can get a better clocking to get it tight. But that's just perfect right there. Okay, one of the big screw ups that I made while I was building all of this, well, that's greasy. I should have wiped it off first. One of the screw ups that I made when I was building this was I did not accurately enough measure my bolt circle diameter, and I should have looked. I'm sure in a Schar's catalog or in some catalog, I could have found this. This is a pretty standard lathe spindle face, and it, you know, takes a standard hobbyist grade chuck. I should have found what that bolt circle diameter was, but I tried to transfer punch this off of a plate, and I got it off, so I had to waller them holes out with a die grinder, and near had a catastrophe on that. This does have just a little bit of a taper on it to center the chuck when you bolt the chuck on. Another thing that I about messed up on was when I welded these flanges on there. I welded them from both sides, and I should have prepared my joint much better than I did, and basically tacked it on the back side and then welded it from the front side to where I got 100% penetration from the front side, and then went back through and ground out the back side and then welded it to where I had a 100% penetration for sure, because when I went to tapping these holes, I found that I had voids down in there, and I had to re-weld, and you can see I even still have a few voids. I had to put this back in the lathe and then V out a whole lot of meat right here, and then re-weld this and return it, and that's what happened right there. I got a little bit close to the edge. And to turn this, since I don't have a bull nose for my live center, I just made me a little plug that slips up in the inside of this. I used a steady rest on the surface here before I even turned anything square or true or straight or anything. I just put this up, put my steady rest on it, let it run on the icky, and then reached in there with a boring bar and bored it as true as I could get it. And I held it from the inside with my 3-jaw chuck like so. And that's how I held it in the lathe. It didn't come out and it didn't slip and it didn't get squirrely on me, so I guess it was okay. But I bored this to where it would fit from both ends. My little plug would fit in both ends. And now the base material that I started with has basically 1 1/4 inch hole through the center and 1 3/4 inch OD. And this was just something I tripped over at the steel yard. I don't even know what this material is other than it's steel. Bearing, bushing stock, round, hollow shaft stock, I don't know what to call it. So, but anyway, now I did come up with a fairly clever way of holding this. It's the way that I weld flanges onto anything. It's in the long video. Sorry, I just can't show it here. I'm running out of time. But this is all weldment. I wished I could have turned this out of a solid piece of steel, but with this little 1/2 horsepower lathe, it was all that lathe could do to turn a 4-inch OD or 100 millimeter OD. It does not like turning big sections of steel. You know, it's a 1/2 horse and it's a Chinese horse. So it is what it is. You got to make do with what you got or buy something better. These holes here, this is my oil hole. This is just, I drilled an 1/8 inch through hole and then put a chamfer on the inside of it to give me a little bit, I don't know, take the burr off basically. I was going to put an oil channel in it, but I figured I'd end up scrapping the part if I did that because I shake like a dog passing peach pits. There's a 3/8 hole drilled down about 5/8 deep. And down in the bottom of that, I've got some little round pieces of diaper. We've got a baby and she outgrew her newborn cloth diapers. So we've got a lot of newborn size cloth diapers laying around that, you know, people really don't want these kind of cloth diapers secondhand. The fancy ones with all the snappy snappers and the liners that go inside, people want those kind of cloth diapers, but not the cheap throwaway ones. Well, they're not throwaway. But anyway, cloth diaper material is great stuff. It's flannel, it's soft. By design, it's not very scratchy, and it's very absorbent. So I cut some cloth diaper material, little plugs of that, and put down in here in the bottom of my oil reservoir. And I just put a few drops of, I use transmission fluid on this. I use transmission fluid and turpentine mixed together for about everything. It's cheaper than WD-40. I've got a pretty good supply of transmission fluid. That's just what I use. And believe it or not, transmission fluid works really good on aluminum to steel interfaces, almost like, you know, it was made for it. But that's what these are for. That's how I made them. Nothing fancy or special about that. Another thing that I did as I was building this, so that I did not get everything all swapped around and goofed up, was I match marked. There's a B, a B, a B, A, and A, and A. I match marked my parts, and I even, just so I didn't get screwed up, I even put a match mark on this, on my end of my spindle. There's a Bravo there, so that all the 11 times that I took this thing apart and put it together as I was making it, I wouldn't get one of these bearing blocks turned around backward or in the wrong, on the wrong cap, or wrong block on the wrong bearing. It helped because, you know, I'm old and easily confused. So anyway, I appreciate y'all sticking with me through this. I know it's kind of a rant and not really was the intent of the video contest, and I may be disqualified for not following all of the rules, but you know, it is what it is. I can't make a 20-minute video on something like this and explain it in any means that makes any sense at all and get the point across with my level of editing. And if you all are regular subscribers, you understand that my level of editing is almost non-existent. So there will be a link in the description to a hashtag that you need to click, and that hashtag will take you to a tool making challenge. And I invite you to like and subscribe to me, and also look at that hashtag, search that hashtag, and watch the other videos in this tool making challenge. We're all in this together. Hey, we love you. Jesus loves you. Y'all drive safe. Watch for deer.